Steel, aluminum, cement, indispensable for us all, but their production is a gargantuan problem for the environment.
If we want to save our climate, our Earth, we need to profoundly change industry.
Because it's heating up our planet, with greenhouse gases and an insatiable appetite for energy.
We have Dubai Grid, and we are comparable in what we utilize for our process.
The rethink is beginning, slowly but urgently.
If radical change doesn't occur in these industrial sectors, we won't be able to hit the targets.
How can the big environmental offenders clean up their act? A climate-friendly commute to work. Dr. Mohammad Safi's routine for 15 years.
I cycle to work whatever the weather. I see it as a challenge, as a task. I need to do my bit, in both my professional and my private life.
But in the workplace, that's not so easy for Mr. Safi. His employer produces steel, making it one of the big environmental offenders. The engineer is deputy plant manager at ArcelorMittal in Hamburg, responsible for the smooth running of the furnaces. Steel. We can't manage without it. It's in buildings, vehicles, and household appliances. But its production is harmful to our climate, and the steel industry isn't the only offender. If you include energy and heat consumption in the math, the industry is responsible for 43% of global emissions, significantly more than the construction and transport sectors. More than 70% of industrial emissions stem from the manufacture of just 3 basic substances: steel, cement, and chemicals. Steel production was responsible for some 3 billion tons of CO2 in the last year alone. Mostly to blame, the blast furnaces. Where the vast amounts of coal are burned. The production of 1 ton of crude steel results in 2 tons of CO2. Normally, but not in Hamburg. Here, something's happening that's a better fit for Mohammad Safi's philosophy.
I'm personally trying to live an eco-friendly life. That's why I'm pleased if the process I'm working in is also climate-friendly and isn't causing lasting environmental damage.
But how's that supposed to work? Climate-friendly steel production? The first ingredient, natural gas replacing coal as a source of energy. This emits less CO2. Ingredient number 2, steel recycling, cutting emissions by 2/3 compared to production in the blast furnace. But researchers see perhaps the most potential in green hydrogen, a source of energy seen as a future replacement for coal and gas, which is expensive and now in short supply. It's a crucial time for Mohammad Safi and his boss Uwe Braun. They're discussing where to locate the new hydrogen plant.
We're the trailblazers. We've got the means to move things in the right direction. But we also need support in a political level. On the one hand, we need vast quantities of hydrogen. We need the green electricity and, of course, the economic framework for our products.
In other words, it's going to be expensive. On the road to emissions-free steel, who's picking up the tab? And how long will it take? Germany's climate action package sets out an ambitious roadmap for the years up to 2030. Economist Katja Schumacher says much of the pressure is now on industry.
A lot still needs to happen before 2030. Emissions have to be reduced by another 30%. The government's official projection report suggests that if significantly greater efforts aren't made now, industry won't hit its targets in 2030.
Some individuals are well on the way to hitting their targets. One of them is Mohammad Safi. He tries to adopt a green lifestyle wherever possible. He built his house in 2012 with environmental protection in mind. There are solar panels on the roof. His heating system runs on geothermal energy, making it 100% climate neutral. But for the engineer, there's always room for improvement. Together with his sons, he weighs up how to make his home even more eco-friendly. At the moment, the roof only has solar panels facing south and west.
It would be good if we could include the eastern side, to use the sun's energy in the mornings too.
Compared to what industry needs to do, his contribution to climate protection is tiny, but
everyone can play a part, whether it's separating trash, installing solar panels, using electric cars or public transport. If every single one of us makes little contributions like these, of course the overall effect will be huge.
But not nearly as huge as measures taken by industry. After all, it's been producing the most harmful substances to date. But can these emissions also be useful? Steel production at ThyssenKrupp in Duisburg. Here, experts are homing in on waste gases from steel production, primarily carbon dioxide and carbon monoxide. In the past, they were usually flared off. Physicist Markus Ohlers now collects them with his plant. His goal, to utilize waste gases as a raw material.
Today, it's not possible to design all chemical processes in a way that produces no CO2 at all. And steelmaking is ultimately a chemical process. The question is what to do with it afterwards. And we think we've found an answer. To pass on remaining CO2 emissions from one industry to the next, where they can be recycled as a raw material.
Markus Ohlers is keen to find out if this can work, together with colleague Tim Schulzke. The engineer from the Fraunhofer Institute has built a test plant to produce methanol using waste gases. Other necessary ingredients: hydrogen and oxygen. Eco-friendly methanol works well as fuel, in the shipping industry, for example. A methanol-powered ferry is already plying the waters between Kiel and Gothenburg. Waste gases for methanol production. If it works, it's doubly useful.
The methanol approach makes it possible to remove CO2 from the steelworks process and turn it into input materials for the chemicals industry. Balancing things out with the steel industry on the one hand and the chemicals industry together means you can pretty much cut CO2 emissions by half.
Sounds like a win-win situation. But how developed is the process? A test.
I'm at the circuit gas valve and ready to open it.
Okay, then I'll count down. 3, 2, 1, open.
The plant must always be operated by 2 people at the same time, for safety reasons, in case toxic gases escape.
You can relieve the pressure now.
Pressure's under 6 bar.
In the gas bottles, a blend of typical waste gases. Carbon monoxide and carbon dioxide, both extremely harmful to the environment. A small miracle occurs inside the plant. The addition of hydrogen creates valuable, climate-friendly methanol.
Ready to take a sample. Open the valve now, please.
Okay.
And there it is, the substance that could eventually clean up steel production. But it'll be years before there's enough of it for large-scale industrial use.
Sampling complete. Please close the valve. Holding this liquid sample in my hand is a big success for me, because it was a real fight getting the details of the project right. And it will be even greater once the first production with waste gases has taken place at the Duisburg Steelworks. But at this stage, I'm very pleased with what I've got in my hand.
A small bottle that represents huge change. If the industry is serious about protecting the climate, vast plants will need to undergo a thorough remodeling. This will take time, but a window of opportunity is about to present itself. After all, many plants have had their day.
Studies have shown that these sorts of investments in industry are due over the next 8 years. And if we make clever use of them, installing and investing in climate-friendly technologies now, then targets might be reached. But this has to happen across the board and not just in individual plants.
Here, it's precisely the other way around. The focus isn't replacing the old, but reusing it. Civil engineer Aminata Boare and her team are here to salvage construction materials, to protect the climate. This office building in Frankfurt is about to be renovated. Usually, much of the discarded material would end up at the dump. It's a waste of resources that are themselves responsible for creating a lot of CO2, says Aminata Boare. She's been commissioned by the real estate company to give a second life to as much of the construction material as possible. The first step, documenting every section of the building.
Maybe it's important that these can be adjusted, that you can make them narrower before you put them back in.
Photos for the catalog. It's hoped even this turnstile will find a new owner.
Theoretically, we can reuse all types of building material. Flooring, doors, stairs, grate sections. They can all be removed and reinstated. We just have to ensure the deconstruction is worthwhile.
Each element is recorded in an app. Anyone shopping on here can ease their climate conscience a little. Reusing material means saving on the CO2 produced in primary manufacture. Ideas like this are urgently needed, but mindset change in the building sector is sluggish.
In Germany, unfortunately, only 1% of materials are currently reused, although sometimes the condition of these building materials is still adequate for reintroduction. Or sometimes they just need a bit of preparation before they can be reutilized. But unfortunately, that doesn't happen.
This means a lot of stuff is ending up at the dump when it could still be very useful, says Aminata Boare. So what about these kitchen worktops, for example? They're showing years of wear and tear.
I'd say heavy use, because for us they're all used.
Then we'll have to change other listings?
Yes, maybe, yes.
It's not always easy.
Floor coverings, for example, that are stuck down or so degraded that they might be polluted. In such cases, we have to think, okay, what can we save and what's out of the question? Every building is a new challenge where we've got to go through all the materials and say, OK, what can we do here?
Gradually, a catalog takes shape. In it, all the available construction materials of a building. Anyone wanting to build something new can take a look. What could suit my purposes? The materials are only removed after they've been sold. Then they're sent directly to the client, with no detours, to keep CO2 emissions to a minimum. Daniel Yeda is responsible for remodeling this building. The real estate developer wants to align the property with current standards, avoiding a classic renovation. That's too damaging for the climate.
Hallo. Hallo,
Not everything has to go. These partition walls, for example, are staying put.
Because they have a timeless beauty and they're in good condition. A fresh lick of paint would be nice, but otherwise I reckon they're totally reusable.
Daniel Yeda sees the future of building as circular.
Investors want to ensure that their money is being invested in sustainable properties. This requirement is undoubtedly more crucial now than it was in past decades. In that sense, it's a must, even if it's more expensive. But it's a process, a transformation. With greater participation, it'll become easier to transform existing materials like these and refit them. It'll also become cheaper and more economical to replicate these processes.
Modifying industry must remain affordable. If it is to be a success, as many people as possible need to be on board. The power of the masses, something Mohammad Safi from Hamburg also believes in. He knows that the climate struggle can't be won through his actions alone, but he does what he can. For longer journeys, he uses an e-car. And he does what we could all do more often. He usually runs the washing machine on eco mode. But the appliance next to it, that's already big league climate protection.
Here on the PV battery, I can see the precise charge level and current power yield. I can also see it on the app and decide whether now's a good time to run my washing machine, dishwasher, or tumble dryer. This also helps me save electricity.
Saving electricity to protect the climate. The solar panels on the roof do most of the work here. As for the new panels for the east-facing side, Mohammad Safi has already ordered them. Power direct from the sun. It works, even in northern Germany. What about places where the sun shines all year round? Places like Dubai. The emirate on the Persian Gulf is aware of the world's appetite for green electricity and has an offer for the climate offenders of large-scale industry. In future, buy solar power from the deserts of Dubai, site of the world's largest solar park. Dubai got rich on oil and gas, but the emirate wants to end its dependence on fossil fuels and is turning its attention to renewables. But is solar power viable in heavy industry? A sector that requires inconceivable quantities of electricity? Aluminum manufacturer EGA wants to test the idea in Dubai. Demand for aluminum is at an all-time high. It's everywhere, from mobile phones to aeroplanes. But production leaves a huge carbon footprint.
Aluminium is a very energy-intensive process. It requires large amount of energy to produce 1 ton of aluminium. To give you an example, we have Abu Dhabi grid and Dubai grid, and we are comparable in what we utilize for our process. We have our own captive power plant run on natural gas. this emits a lot of carbon,
which makes aluminum production one of the biggest climate offenders. The main problem isn't the blast furnaces. Aluminum is smelted from a gray powder called alumina, using electrodes charged with electricity. Just how much electricity can be seen here.
You know, we have a very high amperage passing through the pot line, and that high amperage is producing the magnetic field, and you can see the impact here. You can see anywhere you move, there is no deviation. The magnetic field is there. So this is just an interesting phenomena, but this is because of very high amperage we are working here.
Making just 1 ton of aluminum requires as much energy as a 2-person household consumes in 5 years, 15 megawatt hours. Since January 2021, this power hasn't just been coming from the gas-fired plant. The factory is now linked up to the Dubai city grid, green electricity. To date, it's only enough for 1% of aluminum production. It's hoped that figure will gradually increase. In the factory's control room, the power supply is constantly monitored. A power outage would be a catastrophe.
The pot lines which are making aluminum cannot stand without power for longer hours. So it's like a beating heart. If this stops, everything stops.
So total reliance on solar power is only going to be possible if this is available around the clock, including at night. Through storage technology, for example. This much is clear. Green electricity can improve the carbon footprint of even the most serious climate offenders. Solar aluminum is already generating interest, even though it's more expensive than the regular kind.
Up to 66% of the customer clearly mentioned that they are willing to pay a higher price for a more sustainable product. But what even more important is more than 80% of the people said that responsible organization, as they see it, must invest in environmentally friendly technologies.
In Germany, several companies need no more convincing. The biggest buyer of aluminum from Dubai is carmaker BMW. The aluminum factory in the desert plans to increase its consumption of green energy and be climate neutral by 2050. A loom in Dresden. What's that got to do with climate protection? The answer? What's happening here is helping to cut concrete production, one of the world's biggest climate offenders. Matthias Tietze and his team from Dresden's Technical University have been focusing on the metal framework that's in every concrete wall. Usually, it's made out of steel. Here, carbon fibers.
This material has a very high tensile strength. Steel has a tensile strength of 500 newton per square millimeter, and with this material, we're getting up to 3,000 newton. And consequently, in comparison to steel, we can manage with much less material and save a great many resources as a result.
The problem with concrete? To make it, you need cement, extracted from limestone. Just here at the Dückehof plant, it's fired at over 1,400 degrees centigrade, releasing huge quantities of CO2. There's no way around it. But with carbon concrete, you can save a lot of cement. This is because carbon doesn't rust. Steel has to be protected from rust by a thick layer of concrete. A carbon frame can be encased in a much thinner layer.
Perfect.
Perfect. Perfect. Lovely.
Sehr schön.
Building with carbon concrete from Dresden requires around half as much cement than concrete reinforced with steel. That cuts CO2 emissions by half. comparing two concrete beams.
It might look as though one is less efficient than the other, but that's not the case. They're both equally strong. You just need more concrete to protect the steel from corrosion. That's all there is to it. This beam can be used in the same components, bearing the same weights as the steel concrete on the right.
To showcase its possibilities, researchers are currently building the world's first carbon concrete house, the Cube. They say it'll last 200 years, more than twice as long as a building made of steel concrete. Carbon may be much more expensive than steel, but less of it is needed, which could ultimately even reduce construction costs. Concepts that are helping to ease the climate crisis. Steelworks employee Mohammad Safi and his sons have discovered something for themselves: eating less meat. Its importance for climate protection is often underestimated. Meat production generates more greenhouse gases than global transport.
I eat meat maybe once a week, and fish once a week. I'm not a vegetarian, but I'm increasingly eating like one.
A vegetarian diet can save 450 kilograms of CO2 every year, setting an example for the next generation, says Mohammad Safi.
Our children learn from us when we actually live by our own example, not if we lecture them and tell them what to do. I'm sure my children are also taking it on board, and that they'll live like this too.
It's young people who will be feeling the full effects of climate change. If industries causing the greatest environmental harm act in a timely manner, perhaps those effects can be eased.
It's really crucial that current investments are all channeled into climate-neutral, climate-friendly concepts. If we allow ourselves to invest, perhaps also because of the current crisis, in technologies that aren't geared towards achieving this, then it's a missed opportunity that won't come around again so fast.
Environmental offender, industry. Could it one day be emissions-free? It's a distant goal, but an attainable one.